Okay, so what this is the 2012 Floriculture and Nursery Products numbers for, I guess, 2011. This came out October 2012, and it's a great write-up that talks about different commodities, whether they be cut flowers, orchids, lay flowers, foliage, potted plants, the kinds of numbers and that were grown in Hawaii over the last few years from 2007. It also breaks down almost by the crop, ginger, orchids specifically, different kinds, and the numbers that they were able to make. So it's pretty specific on the numbers. Now, if every farmer was to say contact CTAR or especially National Agriculture Statistics revenue and say, hey, you know what, we would love to have these kinds of write-ups for coffee crops or something in Hawaii, you know, and like besides stuff that poisons the environment and causes invasive plants, maybe something as food crops. And actually they will, if there's enough requests and people are looking for this type of information, they will find funds and go out and come up with these write-ups with all the specific data and do all the work for you. You just need a group that has a lot of pull, like yourselves, when it comes to requesting services. So if a group can get together and say, hey, you know what, we have these 5 crops we're really looking to grow out in Panaewa area. Because of this class we took, we were able to establish that these specific 5 crops would probably be the best for us economically. Is there any way that we can get some studies done for us on it? And you just put in the request. It might take up to 1.5 years, but you can get that data back. And then when you've started your farm and you started things going and you planted your macknut trees and stuff, you can get that data back from them. They actually have one right up for macknut they do every year. But take a look at this, and just I want you to realize that it's a potential for you to use in your business plan development side of the class. An easy project for the business plan side would be to say business plan for a nursery. The numbers are already there. It's all sitting there waiting for you. Just got to go find the information and write up the business plan. Okay. Everybody got a giant stack of paper in front of them? All right, that's good. It's a lot of reading, folks. It's just 4 weeks. You only got 3 left after this one. Just do the reading for these 3 weeks. It's summertime. Go to the beach, do some reading. I have some folks that are asking me about more reading, surprisingly. And they wanted some recommendations as far as a few ideas that interest them, like plant propagation and tropical fruits. I have a book here that I recommend for Hawaii. It's a tropical fruits book written by the Dean of Students for CTAR and another wonderful fruit scientist. So I recommend, if you plan on growing fruits in Hawaii, get this book, guaranteed. And it basically breaks down, I think it's about 14 different kinds of crops, from papaya to longan, guava, caramoya, bananas, avocados. How to grow them, where they grow best, what's the best way to prune them, what's the best way to harvest them, what do you do after you harvest them, how do you prevent bruising, it's all in here. So taking your product to market would certainly help with one of these books. Plant propagation. If you're doing orchard cropping, you better know how to propagate, you better know how to graft, you better know how to work with seed, you better know how to take cuttings and root. Just any farmer should really know how to propagate, especially since the seed industry is changing so drastically that seeds that you can grow at home for pennies are going to start costing an incredible amount of money in the next 5 to 10 years. So if you're looking for organic seed, like organic lettuce or something like that, you're going to be paying about as much per pound as you do for the lettuce, which is like $12 a pound or something. So just a pound of lettuce seed is not that much. So it can be very, very, very expensive. So learning how to grow lettuce for seed and then growing baby greens with it. Strongly recommend this book. It's as thick as they come. Oh, I forgot one of my books. I'll bring it next time. Just general plant biology. You don't have to get this one. If you have any concerns that you do not know enough about plants, okay? Especially on the next lecture. If you don't feel that you know enough about how plants take in water, how do they breathe? How do they exhale? What kind of gases go in and out? How does sunlight and carbon dioxide get turned into sugar? I mean, that's huge. If you don't understand that, go to a bookstore for UH, buy any plant biology book, botany book, buy it, read it, use it as a reference, okay? I also have a soils book, which I'll bring next class, and I recommend you learning how to read that one. All right, we're going to talk about cropping systems, and we're going to go see some pigs. How's that sound? Yeah. All right, I didn't put a timer. What's the time on that thing? And I'll start my phone. Boy, I'm starting late. That happens. 5 minutes. All right. Okay. Wow. Okay. Cropping systems, folks. I'm going to talk really generally today. I'm going to scare you about how simple a lot of this is. I'm really just dropping a seed into your brain, talking about business ideas, okay? You may know a little bit about hydroponics. You may know a little bit about aquaponics or soil cropping. I might bore you to death if you know everything about these things. Stick with me, and then next class I'll scare the crap out of you, okay? So whatever's easy now, just think of it as a gift, and then just save that, save that energy for next week. But we're talking about cropping systems today. Cropping systems, these aren't the only types, but these are the ones that I've researched work best for areas like yours. Soil cropping, provided that you have soil. We'll talk about that in a second. How do you get soil if you need it? Hydroponics, very, very popular fad. It's been going on for about 20 years. Aquaponics, even more popular nowadays. Aquaculture, we'll talk about the differences between those. Orchard cropping and nursery cropping. All right, I'm going to spend probably the first third talking about soil because soil dynamics and soil really comes into play in pretty much any one of those systems. Even if you're talking about hydroponics and you don't, a soilless system essentially, a lot of the same factors come into play. And anything I reference here will certainly come up for the next class. So take good notes, all right? What is soil? Okay. First of all, it's soil, it's not dirt. I'm a soil scientist. I get offended when you say dirt. If you say dirt, I just look at you and I'll stare you down until you change it. Because dirt's on your pants, soil is stuff that gives us life. So what is soil? It's essentially weathered rock. It's rock that's been broken down through erosion, whether it be physical or chemical, and broken into small parts. And that rock would be originated from a parent material. Okay? Parent material is essentially going to be the original rock on which soil has been created. So if you have a large granite boulder as big as me, and you have a large volcanic basalt rock boulder as big as me, they're both going to make soil over time. Eventually they'll break down to medium-sized pieces, smaller. Which one's going to erode faster? Certainly the volcanic rock. Mostly because of one thing, and that comes down to surface area. There's a lot of pits and divots and a lot of surface area that if you were to, say, measure with a computer the surface area that's along a basalt rock versus a granite boulder, the surface area of a basalt rock was probably going to be 17 to 100 times bigger. So it'll probably erode 17 to 100 times faster. Okay? It really has nothing to do with the hardness of the rock, because rock can pretty much resist weathering. That's physical but not chemical. So when you get water involved, water starts evaporating, temperature changes, especially in colder areas. Where I come from, Chicago, you drive down the highway in the spring, and what happens? You're doing this down the highway because all the roads have buckled, all the ice has gotten in the cracks, separated things, moved them around. So that typically happens with rocks as well. And it actually happens, Mauna Kea. Higher temperatures above 5,000 feet will actually cause major changes in the way water behaves because of its temperature, and can cause more erosion at a colder temperature. Okay? Plant and animal remains are also a component of soil. You can have soil without those, but as far as agriculturally, you wouldn't even want to get near it. So we're talking about Gobi Desert, we're talking about dry areas that don't have a lot of organic matter, or areas where that organic matter has been washed away. So it might not be super dry, it could also be super wet, super rainy, and there won't be any plant or animal remains. So the plant animal remains have varying stages of decomposition. This comes into play when we talk about mineralization, which is going to be the change of minerals that are contained within organic matter, like leaves, twigs, or poop. So as the organic matter starts to break down with the help of microorganisms, those nutrients will change form. So the nitrogen that is in that leaf, as it starts to break down, will change forms. Remember I talked about the different forms of nitrogen. Can transfer from nitrite to nitrate, and if not used correctly or in anaerobic conditions, it can go to ammonia. So when I finally put the video up, you guys will understand what I'm talking about. So varying stages of decomposition is certainly a factor. Let's talk a little bit about parent material. Oh man, I forgot to print off your homework. I gotta do that before you leave. When I did your homework last time, for the last class, I assigned a question, which will be on your homework, which is, what are the parent material in Hawaii? Almost everybody got that wrong, so I want to make sure to clarify it correctly on this slide, okay? There are many types of parent material. There's limestone. Limestone comes from where? From where? A beach sand? Well, it comes from life, right? So think about what is beach sand. It's essentially coral skeleton, right? And its shell's all broken up. And that's calcium carbonate. So it's a calcium material that is made by animals and broken up to a bunch of pieces. And then what happens then with limestone? Usually pressure, time, and temperature change. So if you're thinking about the Southwest, Arizona area, Utah, those areas of the Badlands and all that stuff, what was that area? Was it about 20 million years ago? It was the ocean, right? So it was all under the ocean, and you had all those diatoms, small one-celled organisms that drift throughout the ocean. Little plankton is what they're called. Those die. They have a calcium shell. They fall to the bottom of the ocean. Pressure from a lot of water, eventually time sets in, and you have limestone. Limestone is made up of animals. What's the chemical compound I just mentioned? Calcium carbonate. So when we're talking about limestone, think calcium comes into play when you're liming your soil. When you lime your soil, what are you putting in your soil? Limestone. That's what you're putting in. Granite. Granite is a volcanic rock. It is made through volcanic explosions and all that good stuff, but it's not made from the same materials as you'd find in Hawaii. It has a quartz content. So granite is usually made up of silicon and quartz. Two of the hardest things on this planet. So it's usually going to be a large percentage is crystalline quartz, and it breaks down very slowly, being that it's one of the hardest materials on the planet. And so when you see the gray stones, Pacific Northwest, It's a volcanic area. Washington, right, has volcanoes and all that stuff. But why don't their volcanoes look like our volcanoes? And why aren't they the same color? It's because they have a different parent material coming out of them. When the stuff shoots out millions of years ago, it was quartz and silicon. It wasn't what we have. We'll get to that. Sedimentary. Where does that come from? Some, yes. It comes from plants and broken down rock from water. So usually in waterways, think of the Grand Canyon, sedimentary. What is a Grand Canyon? It's just a river basin that has been there for 10 million years. Colorado River, coming up from the mountains, water comes down. It was at one time, the river was as wide as the Grand Canyon. Slowly and surely the amount of water has come down, erosion has happened, and as the water would flood through, you'd bring down pieces of granite rock and also plants and animals. Break it up into silt. Silt being just a particle size of dirt. We'll get to that in a second. Ooh, I said dirt, didn't I? I caught myself. So sedimentary is going to be the result of erosion, water movement, time and pressure. Sedimentary rock gets eroded really quickly if you look at the Grand Canyon. It's also very dependent on the climate on which each layer, when it was formed, as the floodplain would expand and get smaller, what is that layer made out of? So every time that the water would come down from the winter in the winter melt in the Colorado River, every time it comes down, it doesn't always bring the same stuff. It might bring higher levels of carbon because there's more organic matter this century than last century. And so the bottom layer would actually be harder. That heavy organic layer will be a little bit softer. And then all of a sudden there was a fire, took out the entire area, and then for 200 years there was no organic matter. What did you come down? A lot more granite rock, a lot less organic matter, a little bit harder. So as those layers build, it's softer, harder, harder, softer, harder. It starts to erode differently. And then that's why you have the amazing erosion in the Grand Canyon, and pretty much all other sedimentary rocks makes a pretty cool erosion pattern. Okay? So those are the three different kinds. And then we have volcanic in its separate category. I know granite is volcanic, but volcanic is usually going to contain different materials. Do I have a slide for that? Yes. Hawaiian parent material. This is, I think, on your homework. 3 components found in Hawaiian parent rock, which is called basalt. Basalt is usually a combination of these 3 materials that I'll tell you in a second, but it can be formed in several different ways. It's actually pretty much 3 different ways. Terrestrial, with an explosive type eruption, lots of gases getting mixed around, lots of pressure. You can have terrestrial, where it's more like a shield volcano like we have here. And then you also have the underwater eruption, which usually is not explosive. It's usually going to be more of an oozing kind, right? So the way it exits, the temperature and the pressure in which it exits will dictate what is in it. It's not really what is in it, but what percentage of these 3 materials are in it, okay? Oop, we didn't talk. Here it is. I'm just going to tell you. I didn't put it in a slide, apparently. Okay, first one is pyroxene. Pyroxin. Next one is called calcium feldspar. Feldspar. And the last one, which you should be familiar with, would be olivine. That's peridot for folks off Hawaii. It's known as peridot. It's the green sand you find at Green Sand Beach. It's the green sand you find in all the lava out there. And that's a very, very soft crystalline, green crystalline mineral. So those three are what Hawaiian soils are made of. Please get it right on the homework. Environmental conditions dictate how the soil is made. The most important one, obviously, is going to be rainfall. As rainfall increases on any one of these rocks, so it's not just Hawaiian soils, but all rocks, as rainfall increases and weathering increases, the resulting of the erosion is basically going to be a loss of nutrients. So, for example, you have some soil. Picture some soil in your backyard. As rain comes down over decades and starts beating away and eroding at those chunks of rock, minerals start becoming available. Oh, I stole your pen. I'm sorry. He needs one over there. Minerals start eroding off in addition to clumps of rock, right? Well, some minerals tend to bond with water, meaning that they're water soluble. So the first minerals that are going to break down when water hits it are certainly going to be the water soluble minerals. These are going to be the ones that can leach into water and become an aqueous solution. You lose a lot of nutrients. When you're losing a lot of nutrients, there's something going on called ionic exchange. We'll talk about that next class in detail. When ionic exchange happens, what's happening there is minerals that are like the ones you see on the periodic table will have a certain charge. They have a characteristic about them. They tend to bond with other molecules, or they tend to bond with other surfaces based upon their charge. Okay, we'll get into this a lot more detail. But when that happens and you start losing nutrients, that you could basically cross this word off and put charge. Okay? Once erosion happens, you're losing a lot of your charge. You're losing a lot of your minerals, and then what happens is your pH lowers to an acidic level. And we'll talk about that next class. Vice versa. You're in Arizona. There's no rainfall. There's no weathering. Or slow weathering. You're going to have a high salt content in those types of areas in your soil. Because one of the most readily occurring minerals in soils, after plants have had their way with the soil, after they've gone and had a relationship, what's usually left over is two things: hydrogen and salts, sodiums. So once the plants take up all the good stuff, they got acidic conditions. They also have, not acidic conditions, high salt content. You're less acidic in this region because those hydrogen molecules that are released from the plant, they tend to bond with soil surfaces, and then, how do I describe this? Let's see. They bond with soil surfaces, the hydrogen atoms stick to the soil, and they don't transfer anywhere, okay? Which leaves a less acidic or alkaline condition. So we're on the other end of the spectrum. So you're closer to 7, 8, 9 on the pH scale versus the 4, 5, and 6. You have a high pH, like I said, alkaline conditions. Another environmental condition that breaks down, creates soil is going to be wind, temperature, and sun. depending on your moisture content, wind can affect your soil, because soils that have broken down to the smallest size possible, which would be clay particles, if it doesn't rain a lot and you got a lot of clay and the wind blows, what happens? Gone. Your soil can actually blow away and move away to other places. So we're talking about environmental conditions. You could have high erosion. You could have an area that had high erosion in the past. We're talking 1,000 years ago. An area like the leeward side of Oahu. Lots of clay. Had a lot of erosion a long time ago. But now it's just clay with no rain. So you can lose your soil. You have the buckling of layers because of temperature. Remember I said in the roads, and because of temperature changes, you can have bucklings of your soil layers, which causes mixing within your soil. Bringing clay up to the top can cause loss of erosion. Sun. Sun can beat down on soil, drying it out to the point where water, once it does come, cannot penetrate into it. It can cause a hard, cooked, baked layer on the top of your soil. Once water comes in, it just rolls right off and goes to a waterway. It doesn't actually go into the soil. So that's a way that sun can affect it. Also, it dictates the moisture content of your soil, which can dictate how your soil behaves and how it's created. Am I confusing anybody? Everybody feeling okay right now? Not too hard? Let's talk about soil that you used to farm with versus the underlying rock. Soil is going to contain relatively high organic matter content compared to the rock below. That makes sense, right? Plants grow in it, they die, they break down. They pretty much stay up there. They don't just move 6 feet into the soil, into the rock, right? Soil contains organisms and roots. So folks that are growing citrus trees in rock, they have roots in that rock, right? That makes that rock soil. It has microorganisms in there. Why? Because the plants are in there. So you could have gravel, essentially. But you can definitely grow something in gravel. People do it all the time. Soil is going to be more intensely weathered than the underlying rock. Why? Because the water hits it first and breaks it down when it rains. Temperature changes and wind hits it first. Needless to say, it takes a really, really long time to have deep, eroded soils like Honolulu or pretty much anywhere Hamakua Coast. Characteristic horizontal layer is called horizons. Oh, didn't include my photo. Here you go. This is what it is. Okay. Top layer usually going to be partially decomposed organic matter. Go ahead and start over.